Hey Savvy people, it's Savvy Nick here, and today I plan on continuing with the Python tutorial and learning about Python. In the last stream, we learned a lot more about tuples, sequences, the delete statement, nested lists, and queues, which are all related to data structures. Today I plan on continuing using the tutorial here on the python.org website, which we've been using. We are on the 5th chapter, and I think today we will be able to finish up the 5th chapter. And it's nice to see some familiar people here. Sai, thanks for coming, and Snipe, nice to see you. Hi there. All right, so what's coming up next here in this 5th chapter? We have, let's see, I believe we have sets. That's where we left off here, 5.4. And we also have dictionaries, looping, and more conditions. So that's pretty much what we're going to be covering today. Let me just get ready here. Metsu, nice to see you too. That kind of rhymed, didn't it? Good to see you. All right, so let me get Visual Studio Code up, and let's create a new file real quick. We'll call this lesson, where are we at? 7 now. Great. Just in case we need to write some code here, and so we can follow along. I'm going to keep it on the right-hand side over here, and let's make this a little better. Perfect. I think this is the best flow here. So let's talk sets here. Let's check that out. All right, so Python also includes data type for sets. A set is an unordered collection of no duplicate elements. All right, so basically what it's telling us is that a set exists but cannot have the same element repeated more than once in here. And instead of, let's see, it looks like we would use these curly braces. All right, so we can do unions, intersections, differences, and symmetric differences. And like I was saying, curly braces, we'll be able to create a set. And in order to create a empty set, you have to use set here with parentheses, which is kind of unique. I'm not sure why they just didn't use the curly braces. Okay, because it creates an empty dictionary, it says here, which we're going to be learning about next. So let's go ahead and give a set a try. Let me bring this up, and hopefully everyone can hear me all right. Let me know in the chat if you can hear me pretty well and the audio is good. So they're using a basket, and the basket is full of some stuff. So what is it full of? An apple, an orange, and a few other things. I'm forgetting my magic line, but I'll come back and add that in here in a moment. So pear, orange, and a banana. All right. And can't forget the special line here. So in order to use Python, we need the exclamation point, pound sign, and Python. Let's make sure we can run this. I'm going to move this over a little bit. I got this backwards, I think. Yeah. So we need hashtag, pound sign. And it runs fine, so we know we're good. And we created our first set. In that set, we can search for something, it seems like. So if we print the basket, let's see what we get. We get an invalid syntax. Let's see. Amazing. Well, let's try something we know works. So let's just make a list. And in the list, let's just add 1, 2, 3, and print the list. Oh, I might be stuck in something here. Let's try this again. Okay. Yeah, I thought everything was correct too, and it was correct. It's just I was stuck in the Python interpreter for some reason. I don't know why Visual Studio Code messed me up like that, but it did, so we were doing a lot of nothing there. I just didn't realize we were still in the Python interpreter. Sorry about that. All right, back to this. So we should be able to run this. It's probably something I did. I don't know what I did though. Alrighty, so now we were able to go ahead and print that set. And as you can see in the set, we don't actually have apple repeated twice. Let's see what else. So we have orange twice in here, but that's not repeated either. So when you're printing this basket, it's actually removing any items that show up more than once for us. So that's the big difference here in using a set clearly. And let's continue here. So we can do quick checks, it says. So we can do, let's say, orange. Let me spell that right. Orange in the basket. And let's see if we can just print this out, hopefully. And it says true. So orange exists in basket. It's a quick way to do a search. And that's pretty impressive. So we can also search for something else. So let's just do kiwi, another type of a fruit there in the basket. Is there kiwi in the basket? It should print out false for us, and it sure does. So you can do checks on various items inside of a set by using whatever you're searching for and then the in keyword and just placing your set in, and it can search through the entire set for you. It's actually pretty powerful there. So continuing on, looks like we can do a set and they're using abracadabra. And for B, they're doing alakazam. So let's do the same. So we have two different sets, and the first one we're setting to abracadabra, second one we're setting to alakazam. I'm going to go ahead and just comment those out. If you're new and stopping by to watch the stream today, make sure to subscribe below and hit that notification bell for future streams. Let me, real quick. Okay, nothing new. All right, so let's print out A. So what should we expect? Well, we said before, it only prints out unique letters or, well, unique letters. So these, we should expect not all these letters to show up because they're repeated multiple times. So A shows up many times, so we would only expect one A to get printed out. So let's give that a shot. Okay, in the A set, they print, in the A set, we printed out B, D, C, A, R. And that's what they got in a different order, though, which is fine. And it didn't print out anything that was repeated in here. So only the unique data. All right. So for B, we should expect something similar. So let's just do B in here. And sure enough. All right. And with that being said, let's try out some of these operations here. So we can do, it says A minus B. So A minus B. And that says letters in A but not in B. So letters in here but not in here. So what are those letters? Let's check. B, that's true. There's no B in set B. D, that's also true. And R. None of those letters show up in Alakazam. What a great way to do some fast checks here. So the next one, let's do print A type B. What does that show us? So letters in A or B or both. Letters in A or B or both. So that's all the letters, I would assume. All right. And following that, we have A and B. So that just shows us letters that are both in set A and set B. So the only ones that show up in both are A and C. Very easy to do these checks. It's great. All right. What else we got? The last one seems like we have a check for letters in A or B, but not both. So unique letters that exist in either or. So let's do that. So MDLZBR. So since A shows up in both of them, it does not include it. All right. And then similarly to list comprehensions, set comprehensions are also supported. So you can fill up a set using for loop, in, and then some kind of conditions. So much of the same stuff we did last time with list comprehensions. We won't go back over that. We'll just continue on to dictionaries. All right, in dictionaries, it says it's another useful data type. Dictionaries are sometimes found in other languages as associative memories or associative arrays. Unlike sequences, which are indexed by a range of numbers, dictionaries are indexed by keys. All right. Which can be any immutable type. Strings and numbers can always be keys. Tuples can be used as keys if containing only strings, numbers, or tuples. If a tuple contains any mutable object, either directly or indirectly, it cannot be used as a key. All right. So dictionaries can be thought of, and here's the key word here, which is key value pairs. So much like JSON strings. And they're separated by commas, these key value pairs, and braces. So very, very similar to a JSON object string. So you have in JSON also key value pairs, and so does this, and it looks much like what you would see in JSON. So dictionaries. Let's give a dictionary a shot. And I am going to also comment out what we did here so we can move on to dictionaries. We have tell And we can use savvy, putting in some type of a number, so whatever, 490. And in order to separate, we need our comma. And we'll do Nick here. Why not? 413. And then, okay, what are they doing here? Okay, so they're adding another, so tell. We can add another name, so I'm just going to do Mike equal to 412. And then we'll print out tell and see what we get. Here we go. So all that this did here is concatenate a key value pair into this tell dictionary. All right, and if you're tuning in or if you've been here for a while, make sure to hit that like button. It really does help me out. We'll keep moving on here. We're learning about dictionaries at this point in Python. So what can we do with dictionaries? We just concatenated a key value pair into a dictionary. And if we specify what key we want to print out, we can do that, it says. So if we just do tell, let's see what we're going to tell savvy here. So if I do tell savvy, we should expect 490. So let's do that, and we get 490 out. Great job. It's great that Python supports key value pairs natively. It's a great thing. And if we want to delete something out of here, we learned our special del keyword from last time. So del, and I'm just going to erase Nick, and then let's print. So I'm going to print this twice so we can see what happens. Print tell, and then we're going to print tell after we delete. I suspect that we're going to delete Nick's key value pair. And that's exactly what happened. Okay. And again, we already did this, the concatenation part. So to add a key value pair, you can do it by referencing the key and setting the key equal to something. So that just added one, and then they did list tell. So it looks like they made a list out of tell, and when they did that, it just displayed the keys. And then they did sorted tell, so they just sorted the keys alphabetically. And then they just, well, we already did this, so they're just searching for a string inside of tell, and that comes out true because it does exist here in this dictionary. And Jack not in tell, so they're making sure that Jack doesn't exist in tell. Well, it does exist in tell, therefore it comes out false. So I think we understand how to use all that, so we won't be repeating it. Let's see what we have here. The dictionary constructor builds dictionaries directly from sequences of key value pairs. All right. So instead of having to use initialization like this, you can also do it in this form. Nothing special here. So it's building a dictionary, and that's really it. In addition, this dictionary comprehensions can be used to create dictionaries from arbitrary key and value expressions. So you can use comprehensions again in order to fill out a dictionary. Very cool. When keys are simple strings, it is sometimes easier to specify the pairs using keyword arguments. All right, so this is just another way to go ahead and define a key value pair. You can just set a string equal to some value and it comes out. So let's just, I'm going to give this a shot. All right. So I'm interested in just one thing here. I'm going to add a string in instead of what they did, numbers. So my value is test 1, test 2. Does that work? It does not, it seems like. Right. So let's see if we specify that it's a string. Does that work? Seems to work. So it's interesting that this here can be a string without actually any quotes or even, yeah, well, just quotes or single quotes. But you can, seems like, well, this is a, let's see, we got to set this to something. So let's just use tell again and print out tell. See what we get. And like I suspected, we have a key value pair of the keys are strings as well as the values are strings. So you can do it that way if you wanted to. And then we'll move on to the looping techniques. All right, in the looping techniques, they define a dictionary of nights, and then for K and let's see, KV in nights items, they print K and V. So they just print out both the key and the value pair by simply doing, all right, so let's just do it here. So for KV, you can use any letters you want. Not nights, we have tell here, and we'll just do items, which is a special function. I guess it references all the items inside the key value pair of the dictionary, and we'll just do print KV, and all the KV that they have here is probably just represents key and value. So let's see, we print this out, we should get SAP test 1 and Jack test 2. Looks great. Let's continue on. So now we know how to go through each of the key value pairs very easily with the for loop. When looping through a sequence, the position index and corresponding value can be retrieved at the same time using the enumerate function. So what does this do here? For IV in enumerate, tick, tack, toe, print I and V. So this just prints out the first element, or sorry, whatever element you're on, and then the actual value inside of a list. So we're just being shown different ways we can loop over, various different data structures, really. All right, what if we want 2 or more sequences at the same time? The entries can be paired with the zip function. So there's apparently a zip function here, which allows us to put things together. So let's see, what do we do? So for Q and A, so for questions and answers, they're just using these letters here for that. In zip, and the zip pushes these, well, pairs these two together. So the questions list and the answers list, and we have name, quest, favorite color, and questions. Lancelot, the Holy Grail, and blue for answers. So for QA in zip, we're going to print out what is your, then the question. So the first question is going to be name. What is your name? Is it Lancelot? And I assume this .format QA here is how relates to the 0 and this 1 here, so it can show up in the proper spot within a string. And that's what they get out. So let's just run this real quick. Go through it real briefly if we want. Comment out this top and make sure we have our indentations correct. Run that. We have a problem. And that's because this is lined up wrong. And here we go. What is your name? It is Lancelot. What is your quest? It is the Holy Grail. And what is your favorite color? It is blue. Very good. Exactly what they got, as expected. And finally here, to loop over a sequence in reverse, first specify the sequence in a forward direction and then call the reverse function. Okay, so I was wondering about this earlier in the tutorials. So you can actually just use this reversed function in order to iterate through your given whatever. Given, let's say, list in reverse if you wanted to. Okay. To loop over a sequence in a sorted order, you can use sorted. So here, in a sorted set, so the set will make everything, will make this list unique. So it only has apple appearing once, orange appearing once, and all that gets passed into the sorted function. So it must sort it from alphabetically. And then for F in that sorted set, print F. So we would expect apple to come out first, banana to come out second, orange to come out third, and pear to come out last, with no repeating elements inside of our original, well, that would be a list. Very powerful there. A lot going on in this data structures, but we're almost done here. There's not much more left, it seems like. We're getting to the end of chapter 5. And I think that actually allows us to finish up data structures, which is very impressive. We've made it quite a long way now. I think we're a little more than halfway through the entire tutorial, and then we can start making some, well, hopefully making some kind of nice projects and programs using Python. All right, so it is sometimes tempting to change a list while you're looping over it. However, it is often simpler and safer to create a new list instead. So it's giving us a hint here. It's telling us that instead of going through and changing our list and losing our data, it's probably better to go ahead and create a brand new list as we're going through things. All right. So what are they doing here? So importing math, raw data, they get some whatever data, filtered data for value in raw data. If not math is nan value, filter data append. So they're just filtering out all the nans here. Fairly simple. I don't think we need to really do this. but we'll go through it real quick. So they got some raw data. They went ahead and put these nans in to a list. The raw data list then gets filtered, but not, this is just a new list with nothing in it. And then for every value in the raw data, so it goes through the entire list of raw data, if, then it checks every single raw data element. If it's not, so it's checking for this math is nan and a value, and that value is these individual elements in the list. And if that value ends up being it says if not a nan value, so this is not a nan value, it's going to go ahead and create and append that not a nan value to the filtered data. And that filtered data will display everything that doesn't contain a nan. So this, and finally this. Easy enough. Moving on. More on conditions. A few more conditions here. All right. So it says the conditions used in while and if statements can contain any operators and not just comparisons. All right, so kind of like what we used up here. No, not really. In, it's more like in, so let's see. Let's look at their example, string 1, 2, and 3. All right, non-null, string 1, or string 2, or string 3, non-null. Okay, so this is just checking. If any of the strings are non-null. And the first string that's going to come out is this one because it reads left to right. So it first checks this one. Is that non-null? Well, no, it is null. So it's going to check the next condition. String 2 does have a string in it. So it is the first non-null string, and that's what gets printed out because this is where the condition becomes true. And it's not going to go looking further. So the non-null becomes this trondheim. So they got all the various different types that you can expect, ands, ors, and then you can put nots in there. So much related to digital logic. And they call it short circuit operators here. So you have your and or not, and you can basically build off of those three. All right. 5.8. I think this is the very last portion of it. So let's just do this real quick, and I think we are going to finish up after that. Very glad that you guys have stuck with me this long. I really appreciate that, everyone. Let me see here. So sequences or sequence objects typically may be compared to other objects with the same sequence type. The comparison uses a lexicographical ordering. The first of the first two items are compared, and if they differ, this determines the outcome of the comparison. If they are equal, the next two items are compared, and so on until either sequence is exhausted. If the two items are to be compared are themselves sequences of the same type, the lexicographical comparison is carried out recursively. All right, let me just see what they mean here. So we have 1, 2, 3 less than 1, 2, 4. 1, 2, 3 less than 1, 2, 4. A, B, C. C is less than C is less than Pascal is less than Python. Okay. So I believe what this is trying to say, and maybe I'm wrong, I'm going to have to read in further into this, is it's checking from the leftmost element compared to the leftmost element and slowly going down the list. So 1, 1, 2, 2, 3, 4. It realizes that it breaks out when it does this comparison that 3 is not greater than 4. Same here, and it's just showing us different types. So I think this is, what was this? A set, a list. There's a lot of terms being thrown around, so I might get some of these wrong. All right. And the only reason this is true is because, so ABC, C shows up later than A, P shows up later than C, and P shows up, well, PY shows up later than PA. So this is, well, this is all true. So ABC is less than C, which is less than Pascal, which is less than Python. That's all they're saying here. And hopefully you understood going through that. So again, ABC, since C shows up later, it is greater than ABC. Since Pascal, or P, shows up later than C, this is technically a greater value than C. And since Python, or PY, shows up later than P, this, or PA I should say, this is greater than Pascal. And that goes for everything else as well. So this one's a little bit unique. So 1, 2, and there's a 1, 2 already here, but there's a -1. So since it has a third element, of course, it shows up a little later than 1, 2. You'd get to 1, 2 quicker than you would to 1, 2 with the third element. And it looks like floats and normal values, so integers are treated the same. So 1, 2, 3 is equivalent to 1.0, 2.0, 3.0. So you can't trick it doing that. And this last one I'm not even going through. Note that comparing objects of different types with less than or greater than is illegal, provided the objects have appropriate comparison methods. For example, mixed numeric types and are compared according to their numeric values. So 0 equals 0.0, etc. Otherwise, rather than providing an arbitrary ordering, the interpreter will raise a type error exception. So if you can't compare things, you will get a type error exception. Well, I hope you enjoyed this stream of going through and using the tutorial on the python.org website. Next time we're going to be exploring, let's see, what was the next topic? So we're done with chapter 5. Congrats on that. We're moving on to modules. So hopefully we're going to be learning about some various different types of modules that we can add in and use objects and functions from. Modules are much like, I think, libraries in C, C++. Let's sneak ahead real quick. Yeah. Well, anyways, we'll learn about that next time. Of course, if you're new and stopping by to watch this stream today, make sure you go ahead and subscribe for the next stream. You can also view this video after the fact and just play catch up if you want. We are, I think, 7 videos deep right now. And I appreciate everyone for being here. Special thanks to Snaith, Metsu, and Sai. You guys have been around for quite a while now following these streams, and I really do appreciate you coming here and staying with me. We'll see, yep, see you later, Snaith. I'll see you on the next one, I'm sure, if you can make it. I do appreciate everyone watching, and I will catch you in the next one. See ya.